Straight in then with quality of communication. So I'll get rid of that because we know that that means 2 extra marks. 6 for maths, 2 for our workings. So first thing you need to do is, or maybe the second thing, but at some point, you know, he pays you a £20 note and he gets £2.55 change. So you're going to get 1 mark for finding out how much did both the strawberries and the raspberries cost together. So cost of both, I've done 20, take away £2.55, gives me £17.45. So I know that is what both the strawberries and the raspberries cost. Okay, so you got marks for doing that. And then Mr. Thomas buys 1/4 kilogram of strawberries. We know how much 1 kilogram is. It's £8.60. So for 1/4 of that, I'm going to divide this by 4 or halve it twice. So the strawberries actually cost £2.15. So this was the cost of both together. This is the cost of the strawberries. So we're trying to find out the cost of the raspberries. So the obvious thing now for our third mark is to subtract the 2. So I take them away, and that gives me £15.30. So now I know £15.30 is what 1.5 kilograms of raspberries cost. But I need to get this 1.5 down to 1 kilogram, which is a little bit tricky. So what have I done? Well, what I've written here is £15.30 divided by 3. Why have I divided by 3? Because I know that 1.5 kilograms is what I've got, which is the same as 1.5. And if I divided this by 3, that would leave me with 0.5 slash a half. Okay, I've just split 1.5 up into 3. So that's what I've done here. I've done £15.30 divided by 3, which is a half. So I know half of a kilogram is £5.15. So then to get this back up to the cost of a full kilogram, I've just doubled it. Because how many halves get you to 1? Well, obviously 2. So the final cost is £10.30. So the last 2 marks is quite tricky, but you get 4 marks for getting to £15.30. Okay, and the last 2 marks is for trying to find out the overall cost. Right, for this question, okay, I need to use all this information, but it does, I need the other page to find out what the question is. So it says here, what fraction of the height of the tallest sunflower is the height of the shortest? So we need to find out the height of the tallest. So the height of the tallest is here, 80. Then the height of the shortest, which is this one here, which is 30. So I've got to write that as a fraction, 30 over 80. But what do you notice? 30 over 80 isn't there. So 30 over 80 simplified would simplify to 3 over 8. Okay, next one. What's the ratio of the number of sunflowers with height less than 55 to those which are greater than 55? So where would 55 be? Well, 55 would be here. So all the way across there, if I just draw a dashed line, how many of them are below the 55? 1, 2, 3, 4. How many are above the 55? 1, 2, 3, 4. So the ratio is 4 to 4. But 4 to 4 would actually simplify to 1 to 1. Same amount. Next one. Dieter's friend Glyn also planted sunflowers. Glyn's tallest sunflower grew to the height of 64 inches. Is this taller or shorter? So if we've got 24 inches here, and our tallest one is currently 80 centimeters, what you should notice is they are different units. So we need to either change 80 centimeters to inches or change 24 inches to centimeters. They do give you this by here. They tell you that 90 centimeters is equal to 36 inches. So I'm going to use this to help me change 24 inches, okay? So you can, also if you do know that 1 inch is 2.5 centimeters, you can just use that, but I'm going to use the one they give us. So if 90 centimeters equals 36 inches, I know I can get to 12 inches by dividing by 3. And if I divide by 3, I would divide 30 by 3, which is obviously 30 centimeters. So if I know 30 centimeters is the same as 12 inches to get me up to 24, I just double it. And obviously 30 doubled is 60 centimeters, okay? It's exactly the same here. This is a nice conversion to remember. 1 inch is 2.5 centimeters, but if you didn't, you could have used that there, okay? So it is shorter. All right, the first thing we need to do here is find out how much a third is, because Ali's mother pays a third of the £660. So first we've got to take that away, find the third, take it off. Once we've done that, we can then split up Alid and Gareth's. So A third of 660, how do you find a third? Well, you just divide by 3, use a bus stop if you have to. That's £220. So that's what Ali's mum pays, therefore what is left is that taken off. Okay, so we got to take off the 220 from the 660. So 440 is what is left to pay. So that's 2 marks just for getting you to the 440. Now we've got to split this up. So in the ratio 1 to 9, well, how do we share in the ratio? We add the parts first. 1 add 9 is 10. So we've got to share 440 divided by 10, which is obviously £44. So if each part is worth £44, Alid only paid the 1, which means he's paid 44. And then for the other one, we need to do 9 times 44, which is going to give me the answer of 396 down the bottom. So Alid's mother paid 220, Alid only paid 44, and Gareth paid 396. Okay, so obviously your final marks for those. Next question, nice and easy to explain. You could use your answers to check they're correct. Well, they should add to 660. Okay, nice and simple. All right, guys. So you know he's 21.13 kilograms is what his bag weighs, and you know the maximum is only 20. So you've got to find out the gap between these two. So you can either change them both to grams first, because all of the stuff inside his bag, which I've hidden, is also in grams. Or you could change all of the stuff in his bag to kilograms. It's easier if you just change it to grams up here. So I know he's over by 1,130 grams. That is how much he's over. So in order to take him back down below, we've got to remove 1,130 grams. So why have I circled the coat first? Well, if we ignore the coat, the rest of these, because we can only choose 2 items, the rest of these, we're going to give me absolutely nowhere near 1,000. The coat's 820, so I got to take the coat out. So that's a definite. Then it's process of elimination. If I add the 200 on, that takes me to 1,020. So the hat is going to be way too small because we need to get to 1,130. So if I add on the 300, that's going to take me to 1,120. So that's a little bit too small. If I add on the jumper then, will that take me over? Well, yes, the jumper would take me to 1,140, whereas the book would take me a little bit too far. So, slightly different way of working here, but what are the 2 items? The coat and the jumper. On to our conversion graph question. They love a conversion graph question. The camera costs £90. How much is this in euros? So 90 is not on here. So you need to choose a number which you can get up to 90. So you could do 60. And then you could do 30, and you could add the 2 together. You could do 30, times it by 3. You could do 45, double it. It's entirely up to you, but my advice would be choose the easiest option. What I've gone with is 30. I've said 30 equals £34.20. So then how many 30s can we get to 90? 3 of them. So times that by 3, 102.60 euros. Okay, so you get 1 mark if you've had a method which is going to work, and obviously the second mark for your final answer. The next one, a meal costs £25. How much is this in euros? So £25 is here. Go up, we go across, and what you notice is it's in the middle of the 2. So to find out how far it is between the 2, my advice would be look at the bottom, because that starts at 0. And if from there to there is a gap of £11.40, then obviously the gap between here and here is £11.40 as well. So half £11.40, which is £5, half of that, it's going to tell me what to add on to get me there, which is going to be £5.70. So I could add on £5.70 now to £22.80 to find what is in the middle of there, which is going to give me the answer of £28.50. Okay. Okay, sticking with Gareth. It's a long old question, a lot of marks available. It started to draw the frequency diagram for you. It's quite easy, this one, because they already give you the scale. All you've got to do is draw the next 2 in the middle. So make sure that obviously the box is the same width, and it goes in line here with 21. That's a lie, not 21, 16, as it says there. And then the next one, 33, 3 up from 30. Okay, nice 1 marker. Next question says, which is a modal group? So modal is obviously the biggest one, or the biggest number here, but because it wants group, it's got to be this one here. That's the group. So the modal group is going to be 1.12 less than or equal to b less than or equal to 1.16. Okay, not the 33. That's the highest number, but you need the group. All right, another graph question. State the fuel economy of the car with the largest engine size. Here's engine size, here's fuel economy. So for the largest engine size, it's got to be furthest to the right, which is this one here, up and across. Where does that take me to? It's a really nice scale. So obviously 24 miles per gallon, hopefully 1 mark. Next one, state the engine size of the car with a fuel economy of 42 miles per gallon. So we look for 42 miles, which is here. Go across, down, but now you've got to be really, really careful with the scale. Zoom in. My advice would be on something where the scale isn't as nice, write what's in the middle of them. So that would be 1.25, that would be 1.75. So by here is obviously going to be 2.25, and hopefully then you can see that it's going up in 0.5s, 5 little squares between 2 and 25, so hopefully you know it goes up in 0.5s, 0.05s rather. So this line here is actually going to be 2.2. Okay, right, next question then. It's quite tricky, this one, where it wants us to find the mean fuel economy of the 5 cars with the smallest engine sizes. So if we're looking at the 5 cars with the smallest engine sizes, we know we've got to be looking this side of the graph. I'm going to be really careful, because if I just cut it off there, right, that's obviously the smallest. 1, 2, 3, 4. A lot of you may think that one, but you got this little sneaky one down here hiding. So we just go across by there. That's 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. And now I need to write down the fuel economy of every single one of these. Add them up, divide by 5, because that's how we find the mean. Okay, so the different numbers here we should have are going to be 12. That's a lie again. 17, 48, 54, 53, 55, and 58. Let's double check all of them. Yep, I'm happy with them at the top there. Now what do? Well, I've added them up, then divide by what number? 5, because there's 5 of them there. So for your final third mark, obviously you get 1 mark for trying to add them up and using the correct numbers. Trying to divide by 5 gives you second mark, 45 miles per gallon for the third and final mark. Okay. Next one, why is it not suitable? Why is this not a suitable average? Well, for the cars in less than 1.5 litres. So less than 1.5 is again going to be this side, the left-hand side, so hide that. Why is it not suitable? Because of this, again, this little sneaky one down here, he's miles different to all the others. If it wasn't there, then it would be a reliable estimate, but because he's not, he brings everything else back down. So you need to be using the words of something like an anomaly or an outlier. Because of an outlier, the 1.25 litre car would only be 7. Okay, so that's gone a little bit further. But as long as you say because of the outlier, you get yourself 1 mark. Okay, and then last but not least, draw a line of best fit. How do you draw a line of best fit? Well, it's got to split halfway through all of them. So once you've done it, before you do it, make sure all of the cars plotted is roughly half this side of the line, half that side of the line. I guess you a mark. So the scatter diagram is, in the last bit, the scatter diagram is more reliable to estimate the fuel economy of cars with engine sizes less than 2.5 litres. So where's the cutoff point of 2.5 litres? Well, that is going to be by here. So let's have a look. If I zoom out again, look at all the dots. This side, what do you notice about the dots? Well, they're a lot more spread. This side, they're a lot closer together, apart from this one down the bottom. So is it more reliable for less than 2.5 size engines than it is bigger? Well, yeah, it is, because the correlation by here is a lot tighter than the correlation on the right-hand side. Okay, and that's all you had to say. I've said here, if you ignore the outlier, then the data's closer. But if you've used it shows a more positive correlation, then that gets you the marks. Okay, guys, you need this formula for this question. This is a trapezium. How do you know this is a trapezium? Because you've got these arrows on there, okay? And a trapezium always has 1 pair of parallel lines. That's what a trapezium is, okay? And how do you find the area of a trapezium? You add the 2 parallel lines, A and B, add the 2, you then times by how tall it is, times by h, and you then halve your overall answer. So A and B on this one are 10 and 12, because they're the parallel lines. You add them, 22, you then times by how tall it is, which is 8, 22 times 8, then you halve your answer. That doesn't need to be there, okay? It's there to throw you. We might need it later, but at the moment we don't. So, again, how do you know this could be area? Well, look in the question. You've got squared everywhere, guys, so hopefully that was a bit of a giveaway. So, as we said, the 10 and the 12 added gives me 22. I then times by 8, because that's the height, and I then halve my answer. So eventually it gets me to 88. So if 88 centimetres is how much 1 is going to need, that falls into this bracket here, 86 to 89. So we know it's got to be £1.50. So if you've got all the way to £1.50, including the 88, obviously, then that gives you the 3 marks. But for the 4th mark, you need to notice that this is for 100 labels. We need 500. So you would need 5 lots of 100 labels to get me to 500. So you then need to do 5 times £1.50. So for your 4th mark, £7.50. All right then. This question is pretty tricky, but for this 1 mark at the beginning, it's quite nice. The smallest face, we want to find the area of it. Well, this is the smallest face by here, which is 15 down, 25 across. So I need to do 15 times 25 without a calculator, obviously, guys. Use Napier's bones, and it gives you 375. Okay. All right, this one is pretty ugly. All right, there's a lot going on here for 5 marks. So let's just have a little bit of a read of it. A customer orders 2 pairs of boxes. Just show you that there. The package for sending these shoes boxes made by placing one on top of the other and then taping the 2 boxes together. So you just put them on top of the other and then tape them up. This is shown in the diagram. The cost for sending the package is calculated using the formula below. So this is a little bit ugly. It says a fifth, which just means divide by 5, times, and then you have to add the S and the F. Well, S stands for value of the sum of the 3 dimensions of the package. So you add the 3 dimensions, and value of the area of one of the largest faces. Okay, so this is quite ugly. What are the 3 dimensions? Well, although you probably think it's 40, 15, and 25, you've got to be careful. You've put 2 together. So by putting 2 together, it's no longer 40, 25, and 15. It's 40, 25, and these 2 added together, which is 30 centimetres. So to find out the S part of it, you add 40, 30, and 25. Okay? So let's have a little look what I've done here. First things first, S. What have I done? As I just said, 40, add the 15 and 15, which gave me 30 up here when I done it. And the 25, 95, okay? So that's the S calculated. Now I've got to find the area of the largest face. Well, the largest face is now actually this side one, because it's 30 up, and then 30 up, sorry, and 25 back. That's pretty big. So sorry, let's double check. This one here is 30 up and 40 back. So that's actually going to be the biggest one. So the area now, this is the largest face. So I need to find the area of that face there, which is 30 times 40. Okay, which is what I've done here. 30 times 40 is 1,200. A little bit tricky. Okay, then what do you do? Well, we know what S is, we know what F is, we just continue to use this now. We add the 2 together. So I've added them together. It gives me 1,295. Now what do? I times by 0.02. So if I'm timesing by 0.02, doesn't matter which way you do this last part. I've divided by 5 first then, because I'm timesing by a fifth. It's the same as dividing by 5. So in a bus stop, you could divide that by 5, gives you 259. Then times by 0.02. So if I times it by 0.02, it's the same as timesing by 2, and then put your 2 decimals in after. So eventually the final answer is going to give you £5.18p. Really, really ugly question that. I thought that was really, really harsh. Okay. All right, guys, for this question, a little bit tricky, but you need to remember how to draw a perpendicular bisector and an arc. So the first part is the hardest part. The same distance from block 1 as it is to block 2. So here's block 1 and block 2. We need to draw directly from the middle of them, but you can't measure with a ruler and do it. We need to use a compass. So my advice would be choose the same point. So if you're going to choose that that corner there, use that corner there, okay? Or vice versa, that one and that one, okay? I'll use the top one, and I'll redraw over what I've already done. So to split perfectly between 2 points, it's called a perpendicular bisector, or I know we've sometimes called it a rugby ball. So you open your compass to just past halfway and draw half an arc. Keeping it the same distance apart, you go to the other side, like I've done there, and draw the other half, whoops, butterfingers, like so. So obviously try and ignore the ones I'd already drawn on it. And as you can see, the ones I have just drawn cross by here and by here. So if I just draw straight through them, that should split perfectly between these 2 points. So we know it's got to be somewhere in between here, on that line. Okay, obviously we already know the answers there, but let's double check it. It says 80 meters from the top left-hand corner of block 3. So if I wanted to draw 80 meters from the top left-hand corner, the scale up here is 1 centimeter equals 20 meters. So we need to measure 4 centimeters away. Now you can't just keep turning your ruler around. It would make sense to open your compass to 4 centimeters like so, put it on the top left, draw an arc away. And as you can see, it's obviously in the same place it was before. So where does our tree have to be planted? Well, by here, because this is where it crosses my green line. Now, if you've just drawn a straight line down by measuring it and not done that, you're going to get you'll get 1 mark. And then you need to draw the perpendicular bisector for the 4 marks. And then if you've drawn the arc of 4 centimeters, you will get 1 mark for that as well. Okay. Next bit, what is the shortest possible distance between block 2 and 3? So you've got to measure straight up and down. What is it? I've measured here as 5 centimeters, but previously said 5.1. You'd be allowed a little bit of leeway though. So 5.1 times by 20, because the scale is 1 centimeter is equivalent to 20 meters. It's actually 102 meters away, okay? Quite a long distance. Okay, I think this is quite a nice question to really get your teeth into. Sam bought 200 trees, each tree costs 25. So if you buy 200 and each one costs 200, the obvious thing to do first is 200 times 25 to find out how much all those trees cost. So you're gonna get 1 mark straight away for doing that. 200 times 25, 5,000. 22% of the trees were not sold. So if you buy 200, your second mark now is, or you could have done this without finding the total cost, is find 22% of 200. Okay, so 22% of 200 is 44. How have I got that? Well, a few different ways, guys. You could find 1%. 1% would be obviously, you divide by 100 to find 1%. 1% would be 2, and then obviously 2 times 22 is 44. Okay, so 44 trees were not sold. So if 44 trees were not sold, we know that 156 trees were sold. Okay, that's where that's come from. I've taken away the 44 from the 200. Go back to the question. Sam sold all of the other trees for £40 each. So that's why I've done 146 times by 40. Again, use Napier's bones, okay? Take your time. 6,240 quid is the total amount of money he's received for selling those trees. Well, how do I now find what the profit is? Well, if that's the money I've made, that's the amount it costs me to buy them. It's the gap between the two of them. So for your final marks, £1,240. Okay, really nice question for 5 marks. That really, really generous. The next question then. The trees are planted in identical pots. They each have a uniform cross section in the shape of a regular hexagon. Show that these pots will tessellate. So tessellate just means if you put them next to each other. So if I drew one by here, and you will get marks for drawing it if you wanted. So and then another one here maybe. Sorry, should go down there. Ignore that one. Because they're all the same shape, if this is 120, that's also 120, that's also 120. Tessellate means fit perfectly. So 320s would get you to 360. So as long as you've shown 3 120s get you to 360, that is why they tessellate. Okay. A bit of bearings now then. So whenever you've got bearings, measure, remember 3 things. You always measure from north. You always go clockwise, and there's always 3 digits in your answer. Okay. Find the bearing of Reuben from Milford Haven. So because we're going from Milford Haven, that's here, to Reuben, this is the angle we need to measure, okay? Now I said always go from north. So north has to be 0 degrees. So I'll zoom in. We know we got to go clockwise, so I need to know the size of that angle. So all I'm going to do is put my protractor on make sure north goes through 0, and it does. 0's by there. I'm going to go on the outside numbers now then, because 0's on the outside, and have a look where it goes through. So mine here goes through 43, I think, roughly. Yeah, 43. Okay, but when I previously done it, I had 42. You'd obviously be allowed a little bit of leeway. Now, the last thing you've got to remember is there's always 3 digits, hence why I've written 042, okay? If you forget that 0, you screwed it up. Next one, find the bearing of Swansea from Reuben. So because, or whatever it's called. So that means I now need all of this angle I colour in green, because we always go from north and we always go clockwise, okay? So I need all of this angle here. How am I going to find that? Well, you notice 180 was only going to get you halfway. My advice would be, just move this away. I would measure the wrong way, so measure anti-clockwise. So now we're looking at the inside number, because 0 always starts at north. I'm going to have a look where my red line goes through, and it goes through 20, which is actually 160, because I was using the inside numbers, 0 all the way around to 160. So if all of this angle here is 160 degrees, the rest of this to here, this is where we had to stop, it's got to be 360 take away 160. That's the easiest way to do it, okay? That leaves me with 200 degrees. Okay, a few different ways you could have done this, guys. I've done it slightly different below, but I'm going to just show you a different way at the top first. We know that to go from Milford Haven to Reuben, it's 90 miles per hour, but we've gone for an hour and 20 minutes. So what I know is I've gone at least 90 miles, because there's 90 miles in 1 hour. 20 minutes is a third of an hour, because there's 3 20s in 60. Remember, times that 60. So if there's 3 20s in 60, 3 90s, or 90 divided by 3 rather, is going to be 30 miles. So I actually go 120 miles, okay? That's quite a nice way of thinking of it. 20 minutes, how many 20 minutes get you to an hour? 3 of them. So if you went 90 miles in an hour, just divide 90 by 3. I'm going to do something similar with this one. If I go 80 miles per hour, I've gone at least 1 hour, so I know I've gone 80 miles, but then I've got to add on 15 minutes. Well, 15 minutes is a quarter of an hour. So a quarter of 80 is obviously 20. Add that on, so I've gone 100 miles, okay? That is a pretty nice way of doing it. The way I've done it below is slightly different. I've done 90 times 80. Where did my 80 come from? My 80 came from the 80 minutes. 1 hour, add 20 minutes is going to be 80 minutes, because 60 minutes in an hour. So what I've done is I've changed it to minutes first and then divided by 60 after. So I did 90 times 80, then divided by 60. And eventually that got you to 120. But like I said, I think that way is a bit easier. So I then done the same method for the other one, which gave me 100. But as we said, I already done it above. Okay, so in total, how far did I go? 220 miles, right? So 2 different ways of doing it. Personally, I prefer the first way. All right, next question. On average, the helicopter uses 0.4 gallons of fuel. Remember, 1 gallon is 4.55 litres. Use this information to calculate how many litres of fuel the helicopter would be expected to use for the flight planned in part B, okay? So, first thing you need to know is, if it's per minute here, it says 0.4 gallons per minute, you need to find out how many minutes you travelled for, and it tells you here, obviously the 80 minutes here, then an hour and 15 is going to be 75 minutes, and 80 adds 75 minutes gives me 155 minutes. You get 1 mark for that. But we know we use 0.4 gallons of fuel per minute, so I now need to times 155 by 0.4. Again, use Napier's bones. So that gives me 62 gallons. So that's what's needed or going to be used. Now I've got to change this to my litres. So if I know that I need 62 gallons and 1 gallon is 4.5 litres, in litres I need to now multiply 62 by 4.55. So again, it's Napier's bones. So if you've got to 62 gallons, you've got yourself 3 marks. Your 4th mark is for showing 62 times 4.55. Eventually then, if you did use Napier's bones correctly, 282.1. All right. A lot of information going on. I hope you've read it a couple of times. There's loads of different numbers going on. So the easiest way is, when looking at this first question, find what links above. How many litres are there in 25 megalitres? So I know I've got to look for the word megalitres first. So this is what we're looking at for this question. 1 megalitre is equal to 1 million litres. So 1 million is obviously written like that. Okay, so if 1 megalitre is equal to 1 million litres, it's the same thing. 25 megalitres, so I'm going to do some workings for this, is obviously 25 million litres. Okay, but now I've got to write that in standard form. Standard form, all right, we know it's not -6 because that's going to be really small. Then it's about just either process of elimination or just remember your method. Standard form has to be written as 2.5. It can't be written as 25. So that's that one gone and that one gone. So it's now between these two. And then how many times do you need to multiply 10 by 2.5 to get me all the way to 25 million? Well, there's 6 zeros on the end, but don't forget you have to change it to 2.5, which means it's got to be 7. All right. All right, next question. Which is the best estimate? I thought this was quite tricky. For volume of water passing through the underground pipes per hour. So if it's per hour, we need to find something up above, which is time. So if we have a little bit of a look, it says here, the lake supplies water through underground pipes of another reservoir at a rate of 230,000 meters cubed per day. So if this is per day, that's 24 hours. So this is why it's a little bit tricky. That's how much it does in 24 hours. This wants me to find out an estimate for 1 hour. Now, 230, effectively, we just got to divide 230,000 by 24. But the way I thought of it is 24 times by 10,000 would take you up to 240,000. So if 24 times 10,000 takes you 240, but you only produce 230 within a day, I felt anything above 10,000 was too big. So that was too big, that was too big, that was too big. So I knew it was between these two anyway. And then I just thought, well, roughly how many 24s will get me to 230? I just effectively ignored the zeros. And it would be close to 9 rather than 8. So I just used a bit of logic, really. So it's between these two, but 9,600 made more sense. All right, a bit of a tricky one for only 3 marks. Lake Vin, whatever it's called, has a surface area of approximately this much. So that means if we looked for a bird's eye view, the area of it could be a circle, a square, I don't really know, has got 4,540,000. That's just on the surface of it, okay? It now says the whole lake contains this many gigalitres. So that means the surface area and then how deep. So if this is the surface area, it's then how far it goes down as well. So what we need to do is find out what have I multiplied this by to get me to this, because it's giving me my volume. To find the volume, you find the area of the cross section. Okay, it does give it to you at the front of the paper. You find the area of a cross section and you times by the depth or the length. We know the area, we don't know the depth or the length, but we know what can fit in it. So at the moment, this is in gigalitres. So you go back to your previous question, it tells you at the top, 1 gigalitre is the same as 1 million meters cubed. So, because it says an estimate, you can do some rounding. Now, I done rounding, I wrote by here what I was going to do, but then I actually rounded by here. I think it makes sense, personally, I think it makes sense to round this first. So I'll call this 60, and I'll call this 5 million, because it's closer to 5 mil, okay? Now I know that there are, so then I'll kind of ignore all these workings now. I'll tell you what, I'll do a little bit neater. I told you the area, to find the volume, it would be the area times by the length. Well, we know the area, we know the volume, we got to find out what to be times them by to get there. So if we've got 60 gigalitres, but there were, as we just said, 1 million meters cubed in a gigalitre, I've effectively got to times this by 1 million. So that is the volume. That's the volume of it, okay? Now what I do know is my area, we already said it was 5 mil, because we rounded it to make it be easier to look at. So if my area is 5 mil, this is my meters squared, this is my volume, I got to find out what have I times by my area by my length to get me there. So we've got all these zeros, it makes complete sense to cross off 3 zeros there, cross off 3 zeros, sorry, not 3, 6. 6 zeros there, and it's the same now that should make it a little bit easier. What should you times 5 by to get to 60? Well, 5 times what is 60? The estimate for your average depth would be 12 meters. Okay, a little bit tricky, that one. All right, when you've got a box plot, remember, if they're turned the other way, then obviously this is going to be the lowest value. Okay, so sometimes they may be turned that way and then the lowest at the bottom, but if they're horizontal, lowest, highest value of the data, so that's the highest number in minutes, lowest number in minutes. The middle one of the box is always the median, and then these two, or the edge of the box, are always the 1/4 of the people and 3/4 of the people, okay? Or the amount of data taken. So if they were 100 students, then this would be 75, that's 3/4, that would be 25, etc. Okay, that's the same for all of the other box plots. So first question, which of the 3 colleges has the greatest range? Well, the range is the difference between the end two, not the interquartile range. The range is, so we're looking for the box plot out of the 3 with the biggest gap from here to there. As you can quite clearly see, it's the first one, but then we've got to find out how big it is. So what is the number from there to there, and then the gap between them? So 55, take away 9. It's going to give me a range of 46. Okay, quite a nice question to start on for 1 mark. All right, next question. On average, if it says on average, when you've got box plots, that word there, you go with the median. In which college did year 12 students have the longest travel time? So I'm looking for the median on all 3 of these, which is furthest to the right. And it's got to be this one here. It's furthest to the right. So why is it this one? Because it had the biggest median of 39 minutes. Nice and simple. Next one, which college has the greatest difference between the median and the lower quartile? Well, the lower quartile is 1/4. So we're now looking for the biggest gap between the median, which is this line, and then these lines here. So which one has the biggest gap? Well, that's quite big. As you can see, that one's bigger, that one's narrower. So which one has the biggest gap between the median and or the biggest difference, the median and the 1/4? It's this one here. It goes from 39 down to 14. Okay, so that was root egg, and the difference was 29 minutes. 39 take away 14. Next one, which of these 3 colleges has the greatest number of year 12 students? Why do you not know? Well, this is just a box plot, and it just says the amount of time. It doesn't say how many people were tested in each school or how many times were recorded. So because it doesn't tell you how many times recorded, you can't answer it. Okay, so that's why only times are shown. Next one, another college. There are 240 students in year 12. The interquartile range of the times taken for these students to travel the college is 32 minutes. How many of these students have travel times within this interquartile range? Well, what you do know about, because it says the interquartile range is always the gap between here and here, here and here, or here and here, which is the gap between 3/4 and 1/4. Well, how many quarters are there between 3 and 1/4? Well, 2. Okay, so if this is 1/4 of the people, this is 3/4 of the people, then obviously the whole box always represents half of the people. So all you have to do to find out how many of the 240 students were within the interquartile range is 120, because it's always going to be half of the people. Bit of a trick question. 75% of the year 12 students take less than 55 minutes to travel. Complete the following statement. Okay, 25% of the year 12 students take less than. So we need to use what we were given up above to help us with this. So if I just quickly sketch a box plot, we don't know the median, but what we do know is 75%, and if it's 75%, 75% is there, because 75% is the same as 3/4. So 3/4 we're at 55 minutes. It then says to complete the, year 12 students took less than 55 minutes. So 75% took less than 55 minutes. Complete the following statement. 25% of the year 12 students took less than. Well, what we know is that the interquartile range is the gap between 3/4 and 1/4. It's these two taken away. Tells you up above it was 32 minutes. So the gap from here to here is 32 minutes. So if here's 55 take away 32 is going to give me 23 minutes. Okay, for this question, guys, which of the 5 countries had population density? For the population density, to find out what it is, you would divide the population by the area. So however many people are in that place divided by the area. Or if the giveaway is, because this one it's asking for 100, which one looks like there's 100 times bigger. And if you look at Austria, 100 multiply 84,000 by 100 is going to get you to 8,400,000. So which one has a population density of 100? Well, it's Austria. Okay. Now the next one, which of these countries had the greatest population density? So for it to be the greatest population density, that just means the smallest area. So again, that's Austria or probably United Kingdom, but then they've got to have the largest or one of the largest populations. So you see with Pakistan, it's 800,000 and then 170 million. So it's quite a big difference. But United Kingdom is a lot smaller than Pakistan. But has, in terms of its population, there's a lot more people in a small area. So which one has the most density in terms of population? It'd have to be United Kingdom. Okay, you could divide them all, but try and use a bit of logic. The last one, which of these countries had a population density that's approximately 4 times the population density of Canada? Well, start with Canada then. So we're going to find the population density of Canada. My advice would be, because there's so many zeros going on Canada, if I cross off as many as you can there. So that's 6. Which means I'll cross off 6 there. So 34 people per every 10 kilometers. So the population density is going to be 34 divided by 10. So for Canada, it's 3.4. Okay. Obviously, I've just done it there where I've crossed them off as well. So if it's roughly 3.4, what number is roughly 4 times bigger than 3.4? Well, roughly 12, between 12 and 15. So we're now looking for one which has a population density of between 12 and 15. And if you go through them all, Argentina is going to be the one, because if I divide the population of Argentina by how many people are there, okay, then what you can see is it would leave us with roughly 14, and roughly 14 is is obviously pretty much 4 times larger than 3.4. Okay, so you get 1 mark for 3.4, final mark for showing Argentina.